In this video, I'm going to talk about backpropagation. So backpropagation, before we start that, I'm going to give you an example, so it's going to make everything easier. Imagine I have 3 courses to study. I have math, I have physics, and I have English. I want to get a good grade, okay? And then I have a limited time. I have 9 hours to study all of these 3 courses, for example. Okay, I have 9 hours and I have these 3 courses. I have my finals. I want to get good grades, and I want to optimize it in a way that I can get maximum grade. Okay, so then I'm gonna say, I don't know what they are, okay? I have never studied, for example, like imagine you have never studied math. You don't know how good you are in math. You have never studied physics. You don't know English. You don't know how good you are in each one of these. This is the first time you're interacting with these courses and you have only 9 hours to study. I'm going to give an estimate. I'm going to say, for example, math difficulty, this is just a random number that I'm going to give to each one of these. Like I'm going to say how difficult it is going to be for me to learn these courses. I'm going to say math is probably 3 units difficult for me to learn. And then physics is going to be, for example, 4 units difficult to learn. English, 2 units difficult to learn. So right now, when I look at this adds up to 9, okay? And then I'm going to say I have 9 hours to study. So I have a limited time, so I have 9 hours to study. So since these ones adds to 9, I'm going to say I'm going to put 3 hours to study math, 4 hours to study physics, and 2 hours to study English. So I'm going to say that now I started studying these. Now I started studying these courses, and I realized that okay, maybe physics is not as difficult as I thought, but like English is more difficult as what I thought. So what I'm going to do is I'm going to reassign these numbers, and I'm going to continuously do this until I find a perfect I find a perfect amount of time to put on each one of these courses. Like for example, the next time I'm going to study for the next exam of math, physics, and English, I will have a more accurate number that I can put here to study. I'm going to say, okay, so now math difficulty is actually 5, physics is 2, and English is 2. I changed these numbers, but I'm not going to exactly change my output that way, because you might have had a simpler math problem. Maybe you are focusing on a simpler math problem or a math topic, and then when you're going to the next topic, it's going to be more complicated, okay? So this way you can't just suddenly completely change the number to you can't just completely like 100% change the importance to something else. It's just it is more complicated than that to just completely change the number. You will change the number over time. Slowly you will change the number, and then you will come up with a very good number of hours that you have to put to study for each one of these courses. First, we assigned an importance or weight to each one of these courses to study, and then we send it forward. We studied that amount of time, and then we realized, oh, okay, maybe I should have put more time toward physics rather than math, because physics seems, okay, maybe I should put more time toward math rather than physics, because it seems that math is more complicated than physics for me. Well, what you basically do when you sent it forward, when you studied that amount of hours, you are going to compare that is a forward pass, okay? And then after you did the forward pass, you're going to compare it with was that hour enough? Like I needed more hour for this, I needed less hour for this. I need and then your error is going to be For example, a math, I was supposed to put 5 hours. For physics, I was supposed to put like 2 hours, and for English, I was supposed to put another 2 hours. Okay, so now you notice you have an exact error. What was the number of hours that you were supposed to put, but what you end up putting in. Okay. But then when you're going back, you're not going to exactly do the same amount of number, because you're going to study another math topic, and then probably that math topic is less complicated. And you say, oh, I have to go back, like physics is going to be more complicated again than math. So you will have this thing keep going back and forth for each one of the exams that you have. And then after a certain amount of time, you're gonna have an overall idea of how much time you should put toward math, how much time you should put toward physics, and so on. Okay. And so we have the error, and then we did the back propagation to fix that error, and then we changed a little bit, and then a little bit more forward. You keep going back and forth until you figure out exactly what the number is. So now that we looked at this example, let's go through an actual neural network. So now let's talk about this. First of all, remember, we talked about this multiple times. These inputs, each one of these inputs are not individual data points. They are features to an individual data point, or if you're doing batch, features of that batch. Like for example, if you're taking the average of 10 data points, each one of these are going to be the average of features of that data point. What I mean by that is, for example, if you have a video of a dog and a video of a cat, and you want your neural network to figure out if this video is of a dog or if this video is of a cat. For example, the features, one of them is going to be the sound that that animal make, and then the other one is going to be like the shape of the ear. So the sound that that animal make, for example, if they bark, it is almost 100% sure it's a dog. And if it meows, it's almost 100% sure that it's a cat, right? So you're gonna give more weight to the sound that they make rather than the shape of their ears, because both of them have ears, even though the shape might be a little bit different. But figuring out from the noise that they make is more accurate rather than the shape of their ears. So that feature is going to get more weight. So these features are going to have, each one of them are going to have a weight, but then when you're getting to the neuron, this next neuron doesn't know about the weights of these anymore. It just knows the weight that this neuron is sending it, okay? So each layer only have access to the weights of the previous layer and not anything else. That is why when you're going back, you're supposed to go layer by layer. You can't just go back and change the weight for this neuron right away. Now let's see how the neural network actually does it. So we do feed forward. We first give random weights to each one of them, like how we did here. We says, okay, I don't know what mass is, but I'm gonna say the difficulty is 3, 4, 2. I'm going to feed those weights. I'm going through the neural network, and then at the end, I'm going to compare the error that I made in calculating how difficult each one of these courses are. And then when I'm going back, I'm doing back propagation, right? So when I'm doing back propagation, I first go to the closest layer to this neuron. And then what I'm going to do is I'm going to say there are 2 weights that are coming to this neuron, weight 1 and weight 2 that are coming to this neuron, okay? And these two are not, the importance of these two are not the same way that we talked about the noise that the animal make, right? So you have to figure out how much weight do you have to give to each one of these neurons that are coming, the values that are coming from these neurons. And that is done through partial derivatives. So, okay, let me write down these important stuff here. So we're doing it through partial derivatives. Okay, I really hope that I spelled it right. If not, I'm sorry. What partial derivatives does is says, okay, if I have an equation, I'm going to keep all of the other things as constant. Nothing, only one variable is going to change, and the rest of them are going to be constant. Okay. If no variable change, I'm going to see how much each one of these features are going to affect the error. So for example, again, in the same example of the video of a dog and cat, I'm going to change the value of the noise that they make, and I see, oh, okay, that's very close, and now I can kind of very closely say if this is a dog or cat. So it reduces the error significantly. So I'm going to give more weight to that feature, and then I'm going to give less weight to the other one. So that is done through partial derivatives to keep everything else constant and only move one of the features at a time. Okay, so I'm going to give weights to each one of these features, but then after you figured it out, when you want to update these weights, you have to consider all of them together. So when you're considering all of them together as a whole, because you have 9 hours, right? So you want to divide these 9 hours between these courses. You know, like math is more important, but how do you know how much do you have to add? That is through chain rule. So partial derivative, consider one weight at a time and update the weights, and understand that how much each one of these courses have importance toward your final grade, or how much each one of those features of a dog and cat contribute to the final error, and how much it can resolve that error. And then you have the chain rule that is going to consider all of these courses or all of these features together and update them all together. Okay, so now we talked about partial derivative and chain rule, and those are both part of backpropagation. So you do the backpropagation, you don't update it at the same time, because you might have gotten to a topic that was easier. So you don't just suddenly change the weights completely. And over time is going to, and that is called the learning rate. So you change them over time, and then over time you're going to get closer to the actual value, to the correct value, and then over time you're getting to the correct value. So okay, we do the backpropagation. When we did the backpropagation, now all of the weights are updated. We went through neuron by neuron, and then we went through layer by layer. We went backward until we. So backpropagation is done. I'm sending another data or another batch in, and when I send another data or batch inside, I'm going to compare it, but this time with the updated weight. So I'm not going to compare it with the 3 that I have here, but when I updated it to 2.5, the next data point, the next topic in math is going to get 2.5, and I'm going to see how that would affect the final error. And then over time I will figure out what it is. So that's basically so that is basically what backpropagation is.